What's going on, guys? This is Junior here, and today I'm going to show you how to build a CI pipeline. Now, before I begin, I just want to say that there are many different ways that you can build a CI pipeline. There are many different tools and many different platforms that you can use to achieve the same. I'm just going to show you how to do it using GitHub and AWS, since these two platforms are very popular. I'm going to show you how you're going to just commit your code as the developer. So you can see that the developers on the left, they're going to push the code to GitHub, and that's going to trigger the entire CI pipeline process until the code is deployed behind a load balancer. And we're going to be coming back to this because this is a very high level overview of the architecture, but there's a lot more that goes into it, and I really don't want to overwhelm you right at the beginning. But we're going to be looking at each component one by one so that you understand exactly what we're trying to do and how we're trying to do it. And one other thing I do want to mention is sometimes you have different environments. So you would have a CI pipeline, but then the code is deployed to a test environment before it's deployed to the production environment. And that's something that's very common because you don't want the code that the developers just worked on to be deployed to the production environment. You want it to be deployed to some test environment or some sandbox environment and have people test the application there before you can deploy it to the production environment or deploy it live, because you have to do user accepting testing on the changes that the developers just made. And sometimes the developers, they understand what they're doing, but there's also a business person. They're not a developer, but they know the business very well. So they might also want to test the code in a test environment or a sandbox environment to make sure that the logic that the developers implemented is correct. That doesn't mean there was like a syntax error in the code or anything like that. It might not throw any exception, but what they coded, like the actual logic, might not be correct. So sometimes you would have many different environments where the code is deployed first, and then after everything's been approved, the application is working as expected, then it gets deployed to the production or to the live environment. And that also brings us to the CI. So when you have the developers, they commit the code and push the code, and the code is deployed. That's the CD part of the pipeline. So that's the continuous delivery, because you deliver something from a simple commit from the developer. But if the code is not fully deployed, then that's continuous integration, because you just push the code and then maybe build some images or build some artifact, but the code is not deployed yet. We have to manually go in and then click a button to deploy the code. So that's continuous integration. But if the code is deployed all the way, like from the developers just pushing the code to the repository, then that's the CD, so the continuous delivery. So I just wanted to mention that. And also, this is not going to be a lot of coding. This is going to be mostly just configuration in AWS and making sure that everything is connected for the pipeline to work. So we have a lot to do. Let's jump right into it. So in the course so far, we've built this fairly complex application, and this is the application that I was going to use for the CI pipeline. But I changed my mind because this application has a lot of dependencies, and as I was working on it, it really deviated me to doing configuration, for example, for database and some other stuff. I kind of felt like it was taking us too far from developing a CI pipeline. So with that being said, I will not be using this application because I don't want to be spending time setting up a database and things like that. And I guess in a way you can say that these configurations are a part of the setting up of the CI pipeline, which is correct. That is true. But this is just gonna make extra work for me. So for example, I would have to define a database for the application, because right now it's looking, well, if I show you what we have in the dev, you can see that it's looking at my local network, which is where I have the database running. So we would have to get some database from AWS or something from online that we can actually use, and then plug the URL of the database in here. And that's just a lot that I don't want to have to deal with, just to show you how to set up a CI pipeline. Because for example, that database will be costly. It's not free. If I have some kind of database like relational database from AWS, then it wouldn't be free. So this is already something that is gonna cost some money, and having to set up a database again will be even more expensive. And I know a lot of you are here for just the learning, but you don't really want to spend any money on AWS, and I don't really want to spend any money on AWS either, but I do want to show you this. So with that being said, I'm not going to be using our application that we build in the course, but I'll be using just another simple application. So back here, I have the Spring initializer. So I'm just going to create something very simple. I have the Spring web so that we can create a RESTful API. And then we have the actuator just so that we can point to the health endpoint to see that the application is running and it's healthy. And also I'm using jar and then Java version 21. Also using the latest stable version of Spring Boot, that would be 3.1.5. So I'm going to click on generate, and then I'm just going to open this in IntelliJ so that we can take a look at it. So I have the application open in IntelliJ. You can see it here, and I just want to create a simple controller. So I'm going to go into the main application. Let's create a package first. So I'm just going to name this, for example, web, because we want to expose something onto the web. And then here, I'm just going to create a new controller. I'm just going to say test controller. Okay. Like I said, we want to keep this simple because I don't want to have to worry about all these other dependencies that the application has. So we're going to be using this simple application. So let's leverage some stuff here. Let's go to maybe the domain. And then we want to grab just this controller thing here, these annotations. So let's copy these and paste them at the top here. Import. Okay. And then we're just going to say maybe test. I don't have this. I'm going to get rid of it. And then let's just copy another method. Let's do a simple get method like this one, and then place it in here. Click OK. And let's put in a little bit of space here. And I'm just going to get rid of this. So it's going to be a get mapping just like that, and it's going to return maybe a string. We can make it return a map or something so that we can see something that's a little bit nicer. Actually, let me do that. So we're going to say map of string and string, and close that off. Test. It's not going to take any authentication or anything. And what we're going to do is to just pass in a map in here. So we're just going to get rid of all this stuff like from here like this. And then we're going to say map not of, and then we're going to pass in a simple string. Testing, and then we're gonna say up and running. Okay, so we just want something that we can like send a request to, but we're not worried about like making it complicated or anything like that. So whenever we run the application, if we go to test, then it's gonna give us this key value pair. So let's run it just to make sure we're good. Just give it a second to start. Okay, here we go. Okay, so we're up and running on 8080. I'm gonna open Postman, and then we're gonna send that request just so that we can see this in action. And I'm gonna create a new request. I'm gonna go to localhost 8080. I'm gonna do tests, and that's a get request, and I'm gonna click send. You can see test up and running. And I can duplicate this. We should be able to go to actuator, so actuator, and then health. That should give us something. Oops, health, send, and you can see status up. Okay, so we know the actuator is working, and we know that the endpoint is working. So now what we need to do is to create a repository and then just push this code to the repository so that we can set it up with the CDCI pipeline. So that's what we're gonna be doing next. So I'm in my GitHub account. I have logged in. I'm pretty sure you guys all have a GitHub account. So just go into a GitHub account, and then you're just going to create a new repository. So I'm just going to click here to go to new, and I'm just going to grab the name of the application. So let's go to the POM file. Just copy this and then paste it here. So that's going to be the name of the application, CDCI pipeline, and everything is going to be the same. It's going to be public. You can make yours private. You'll just have to provide AWS your credentials. But I'm going to keep it public just to keep it simple. And then I'm going to click on create repository. Give it a second. Okay, so the repository has been created. This is our remote URL. So I'm just going to copy this by just clicking here and then go back to our app. And I'm going to open a terminal here. I'm just going to do a git bash terminal and then scroll up a little more. I'm just going to push this code to the repository. So here I'm just going to say git remote add origin. And then we're going to pass in the URL. Well, I have to do git init first because this wasn't a git repository. And then I'm gonna say git add everything, git commit. We're gonna pass in a message, initial commit, git push origin master. Just give it a second. Okay, so it pushes the branch to the master. So if I refresh this, the code should be here. Okay, so this is the repository that we're going to use to set up the CDCI pipeline with AWS. So once you have this in place, you're not going to be doing anything else in the code for a minute. We're just going to be setting up things in AWS, and you can see that I already have AWS open here. We're gonna get to this in just a second. So make sure you have this step completed. This is really very simple. So we're not really doing anything yet. Just creating an application. We create one endpoint to make sure it's working, and then we push the code to GitHub. Okay, nothing's gonna happen. We don't have any CI/CD pipeline yet. So that's what we're gonna be working on next. I wanted to go back to this real quick just so that we can see where we are. I'm gonna zoom in a little more. So far, we have done this part, right? As the developer, we push the code to GitHub. So all of this AWS stuff, we haven't started doing it yet. So we've only done the pushing of the code into GitHub. Okay, so this part right here is completed. So now in AWS, we need to do a number of things. We need to set up something called an ECR, which is an Elastic Container Registry. This is where we're going to be pushing the Docker images. And the AWS code pipeline, or specifically code build, is what's going to listen to the GitHub push. And then it's going to take the code and then build the Docker image and then push that image to ECR. And this ECS, the Elastic Container Service, is watching the registry for whenever there is an update. So whenever there is an update, it's going to say, oh, there's an update. It's going to take the image and then redeploy the application using a number of containers that we will have running different tasks. In this task, they are running EC2 instances in the background, and then we're going to put all the instances behind a load balancer. It might be a little bit confusing, but if we do it step by step, then it will make sense. Remember, we haven't done anything in the AWS sphere yet. We've only done the pushing of the code as the developer to GitHub. Okay, so this part only is done, and it's very simple. We just create an application, we created a repository in GitHub, and then we push the code from our local computer to GitHub. Okay, so now we're going to dive into the AWS stuff. So the first thing we're going to do is going to be to set up the ECR, which is the container registry. Because whenever we build our Docker image for our application, we need to be able to push this image to ECR. So let's go back and let's go to AWS. And one last thing I do want to say before we begin, for the services that we're going to be using, it's going to cost. Okay, it's not going to cost a lot if you just do it and then you see that it's working and then you just delete everything. So it's not really going to cost you a lot of money. But just so you know that these are not free services, you have to pay for them. And also, I'm not going to show you guys how to create an AWS account. So you should be able to create an account yourself, or if you don't already have one, then it should be pretty easy to create one. Or you can look at some resources online on how to create an AWS account. But just know that you're going to need a credit card so that you can have it on file. You're not going to pay for everything because I think they give you like a year of free services. Not all the services, but a lot of the services, they give you like a year for free. So you should be able to try this out. So what I'm going to do is go to the ECR. So you can see Elastic Container Registry here. This is what I've recently visited. That's why it's here. But if you don't have it, then you can just go to this search here and you do ECR and then it should come up. Okay, so I'm just going to click on it and hopefully I don't have anything here. Okay, so I don't have anything here because it's clean. If I go to private registry, nothing. If I go to public registry, nothing. Okay, so let's go back to ECR and then I'm going to click on get started and then we're just going to create a simple repository. I'm going to keep it as private and then I'm going to give it the same name. Oops, it's supposed to be like this. Okay, CI pipeline. This entire thing is going to be the name of the repository. And then I'm going to scroll down and leave everything as the default. Okay, so we just put the name or part of the name. So that's going to be CI pipeline and then everything is the default. And then I'm going to do create repository and there it is. So this repository is very similar to this repository. The only difference is this is hosting code. So we push code in files and folders in this one, but in the registry, you just push images. That's the only difference, but they do the same thing. They're just containers or boxes where you can put your code or some kind of an image. Okay, so that's what this is. So now we have the repository, which means if I go back to the picture, we have this right here, the Elastic Container Registry, and then we created a repository for it so that we can push our Docker image. Now I skip this step because it would make more sense for me to show you this first because it's a lot simpler. So now we're going to turn our attention to this guy right here because it's going to build the image and then push it to the repository so that we don't have to do it manually. Actually, we can't do it manually because we're just going to push the code and then we need to configure things in such a way that the Dockerfile gets built and then the image gets pushed into ECR. So that's what we're going to be doing next. So the way that we're going to connect GitHub to the AWS environment, as you can see here, is by using a service from the code pipeline. I named this code pipeline because this represents the entire pipeline of the AWS developer tools, but I'm going to show you that in just a second. So we need to connect the GitHub to the entire AWS, okay? Because these are not connected. We created an ECR that's just sitting in AWS, and then we have a repo, but they're not connected in any way. And we need them to be connected. So let's go back here, and this is the repository. So I'm gonna go ahead and duplicate this tab, and then I'm gonna search for another service called developer tool. So developer tools. So this is the service that has the code build and code deploy that we're going to be using. Okay, so it says automate code deployment. So we're going to be using this one. If we wanted, we could use code commit. Code commit is like a Git repository, as you can see here, but we're going to be using code build. Okay, so that's what's going to allow us to connect our GitHub repository to AWS using code build. And you can see it's coming from developer tool. So from developer tool, we select code build. Okay, so this is the code build, and then we can do create project. And it's going to take us to this page. Or if you wanted, if we go back, so this is the code build, and then we can just create build project. It will take you to the same place. So again, I'm going to copy that same name. So CI/CD pipeline, paste it in here. We don't need to give it a description. We don't need to enable any of these features. But here, when it says source, we need to connect GitHub to code build. As you can see, we have different options, and one of them is GitHub. Code build is built within AWS. So it's like a repository, just like GitHub, but in AWS. But we have our code in GitHub. So I'm going to select GitHub, and we can connect in two ways because AWS needs to connect to GitHub and then pull the code or the repository. So the way that I would do this is by using an access token, or if you just want to be quick with it, then you can just connect using OAuth. So if I click here, it will just give me a pop-up window, and GitHub is going to ask me if I authorize AWS to connect to my GitHub account. But if you wanted to use an access token, you would have to go to your GitHub, which I think is the better way to do this because you can control how long you want the access token to be valid for. And then you can go to settings, and then in settings, you want to scroll down to developer settings, and then you want to go to personal access tokens, and then click on token. And then here you can already see that I have one. I can just delete it. Yes, delete. And then I can just generate another one, which is going to be generate new token classic. So I can click this, and I can just give it again the same name, and then I can say maybe 7 days because I'm not going to keep this for a long time. As soon as I'm done recording the videos, then I'll just delete everything, which I also advise that you do. Otherwise, you're gonna generate some cost. So then I'm gonna give it some permission, and that's another advantage that you have. You can give specific permissions when you're creating the access token. So I'm giving this token or the repo permission, and I'm gonna scroll down and then click generate, and then I can just copy this token right here, go back to AWS, and then click on this one. So I'll just click on using OAuth. So if I click this, you'll see it's asking to confirm. And if I confirm, it's going to connect to my GitHub using OAuth. Okay, it's already connected because I'm already logged in. It uses the login session that I had. But if I don't want to do that, I can just disconnect, and then I can click on connect using a personal access token, and then I can paste the token here. And I can say save token, and then it's going to connect again, and you can see that I can put the repository here, so it still works the same way. And then I'm just going to copy the repository URL. So I'm going to go back a few times, go back again. So this is the URL of the repo. So this repo right here, and then I'll just put it in here. So that's the repository. And then I'm going to scroll down a little more. And then for environment, I'm going to select the Amazon Linux. Okay. You can select Ubuntu if you want to. I'll go with Amazon Linux, and runtime standard is fine with me. And this, I think we can just do the standard 5.0. Scroll down a little more. For the environment type, Linux is fine. And this is really important. So enable this flag if you want to build Docker images or want your builds to get elevated privileges. So we really need to check this off. Okay, so it's really important that you check this off. And then it's asking to create a new service role so that you can give permission. So I'm just gonna name this CI/CD service role. Okay, I'm gonna remove the leading dash. So this is also really important. We have to remember this name. Okay, so remember where you put this name, or just copy it and paste it somewhere, because we'll need to add more permissions to code build later so that you can access ECR to push the Docker image. And I'm going to scroll down some more, and it's asking if we're going to be using this build spec file. I'm going to say yes, because we're not going to insert anything here. And I'll talk about this build spec file in a minute. And then I'm going to scroll down. We don't have any artifact or anything. And for the log, we can give the group a name so that when we're searching, we can search by this group name. So I can do the same thing again. Okay, so that's the group name for the log. And then I'm gonna just click create build project. Just gonna give it a second to complete. Okay, so the project has been created. And if we want, we can build the project. You can see it says start build. It will pull the code from GitHub and then start building. But we're not gonna do that yet, because what we want to do, we want to be able to build this project. So the GitHub project that it's connected to. So our code, we wanted to build our code and then create an image and push the image to ECR, which is our repository. So since we need an image, that means we need a Dockerfile. So that's what we're gonna be working on. So I'm gonna go back to the application. So this is our app, and in the application that we build in the course itself, we already had a Docker file. So we can just copy this Docker file over. So let's open this project. So I'm gonna click here and then open it. So this is the Secure Capital application, which is the very big and complex application that we build in the course. And I'm gonna click on the Docker file. So this is the Docker file, and I'm just gonna right click and then copy it, and then click on the root folder and then do Control V to paste it. Click OK. So now we have the Docker file added to our application. I'm gonna make some modifications to it. The first one is we have a new version of Maven. So that's gonna be 3.9.5. So I'm gonna change this to 0.5. And we don't need this container port. I also don't need it here. We're just gonna expose 8080. Okay, because we're not doing all the cool stuff that we were doing with all the properties file and the deployments and stuff like that. And I'm also going to remove the versions. Okay, so I'm going to remove the version 20. So it's going to pull whatever the latest version, and everything else is going to stay the same. Okay, so this is the Docker file that we're going to be using to build the Docker image that we will push to the repository that we just created, which is this repository right here. Okay, so now how is this Docker file gonna build this image and push it to this repository in AWS? Well, the way that it's gonna do this is by using a file called the build spec file. So the file that it was asking us when we were setting up the project, we selected that we were going to use a build spec file. So the build spec file is going to have definitions on how to build the image and then push the image to the repository. So that's what we're going to be working on next. So I'm going to go back again to our application, and then I'm going to right click in the root and then create a new file, and then I'm going to name it build spec.yaml. Press enter. So the build spec file is really a file that the AWS code build is going to use to read this file, build the image, and then push the image to the ECR. Okay, so this is the Docker file that's going to determine how our image should be built. So that's just nothing new. Now this build spec file, when the build project, so this build right here using code build, okay, so we created this project. So whenever we click on start build, and this is gonna build the project, it's gonna be looking for this build spec file, and it's gonna run all the commands inside of the build spec file. So what that means is that inside of this build spec file, we need to tell it, hey, we have a Docker file, just read the Docker file and then create the image, and then push the image to this repository. So we need to tell it, here's the repository and here's the commands that you need to run so that you can read our Docker file, create the image, and then push the image to this repository. So at the end of this build, whenever we run this build, when this build is over, if we go back to the ECR, so in this repository here, we should see that there is an image. Okay, so now if I click on the repository, you can see images is 0. We don't have any images. Okay, so it's the build spec file that's gonna tell code build that, hey, run all these commands, which is gonna be, hey, read our Docker file, create the image, and then push the image to this repository. So the build spec file is a pretty big file, and I've already prepared it. So I'm just gonna go ahead and paste it, and then I'm gonna walk you through it because I don't really like to do this, to paste code, but this is an instance where it's okay to paste the code because it's really a lot of code and I don't want to type this. This is not the best use of your time. Okay, so this is the build spec file. It has a version, and then it has phases, and then it has artifacts. Okay, artifacts is in this case just files that we have to define, which is a very important file, which is the image definition file. Okay, AWS is going to use this to do whatever it needs to do, so we don't have to worry too much about that. We just have to define it here as an artifact. So in the phases, we have a pre-build, a build, and then a post-build. Okay, so you can see that we have pre-build, build, and then post-build. So in the pre-build, what we're going to do, we're just gonna echo, so the Linux echo command, we're gonna say, hey, we're starting to log in into ECR. Okay, because we need to log in so that we can push the image. And then we're gonna log the version of AWS CLI that is being used. Okay, so this is the AWS command, and then we're passing in -- version. So it's gonna log to the screen the version of AWS that AWS itself is using. So the AWS CLI version is going to be printed from inside the AWS cloud. Okay, you can imagine that these commands are running in some computer that code build is dedicated to this build or to this project of mine. Okay, so these commands are going to be run inside of it. So we're going to echo this, we're going to echo or print out the version of AWS, and then we're going to echo, we're logging into ECR. And the way we're going to do this is by passing in this command. If you want to see where this command is coming from, you just have to go to your repository. So this one right here, I'm going to select and then click on view push command. And you can see the first one is to log in. So I'm going to copy this and then go and then paste it here. It should be the same thing. Okay, so by running this command, we're going to log into ECR, which is what this is. Okay, so that's where this is coming from. And then we're going to say we're setting in the repository URI, because you have to tell it which repository it is. Again, if you want to see where this is coming from, I can go here. This is the repository. This is it. And then I can see the URI is right here. So I can just copy this, go back here and then paste it. Should be the same. Okay, so that's the repository URI, which is where we're going to be pushing all of our image. And then we have to define a tag for the image, which is this command right here. Okay, this is defined in AWS. I didn't come up with this. So that's the pre-build commands. Okay, all the commands and the pre-build. Now I'm going to collapse this. We're going to go into the build. And again, we have a bunch of commands. We're going to say, hey, we're going to start building and tagging the image. And then we're going to run maven clean install, because we know that we have a POM file. And then we're going to build a Docker image. So we're going to say building the Docker image. So whatever machine that this is going to be running on, which is going to be inside of code build in this project, it's going to have Docker installed. So we don't have to worry about installing Docker or doing anything. Everything is set up by AWS. Okay, so we're going to say running maven clean install, and then we're going to say building the image. So we're going to say Docker build -t. We need to give it a tag, and then we're going to say the repository URI, which we'll define in the pre-build. So this URI right here, colon the actual tag, which is latest. Okay, and then we give it a dot because the Dockerfile is in the same level in the repository, which is right here. Okay, so it's going to say, oh, the Dockerfile is in the same repository. I need to just build it and then tag it with latest. Okay, so we can say it's building it, give it this tag, and then we're going to tag it with the repository latest by passing in the repository of the image, which we define up here. Okay, so we're just doing these commands that we would normally do if we were to build the image and then tag the image. So that's going to be what's going to happen in the build. So after that, the last one is going to be the post build. And the post build, we're just going to push the image to ECR. So we're going to echo this, then we're going to push the image to ECR, and then we're going to do these two commands. So Docker push the URI and then latest, and also the same thing with the image tag that we define up here. Okay, in the pre-build, this image tag. Okay, and then we're going to say echo writing the image definition file. So this file is a file that is needed to identify the updated image for a container and the task definition. So it's just a file that AWS needs to do what it needs to do so that you can identify whenever the image is updated. Okay, so we need to write all of this information inside of this file. And then after that, we're going to echo the Docker container name, which in this case, I'm naming CDCI container. And then we're going to print the definition file just so that we can see it on the log. Okay, and then we're going to set it as our artifact as well. This part right here is just something that AWS needs so that it can identify the updated image for a container and the task definition. And if that's not making sense, don't worry too much about it. Just know that AWS needs this file with this information that you can see we're putting into it so that it can identify the updated image for a container and the task definition. But at this point right here on line 27, we're already done pushing our image to ECR. Okay, so now we just need to push this code to the repository, and then we're going to start the build. Okay, so if we go here, we will start the build. It will pull the code, and then it will look at the file. So this file that we just defined, it will run all of the commands, and then we should see that our image for this application is pushed into our ECR, which we're defining right here. So hopefully that makes sense, and don't worry too much about all of these commands. Most of them are echo commands already, so we're just printing stuff on the screen. And this is stuff that you can find online. I really didn't come up with any of this. It's actually in the documentation in AWS. So you can just go in and just copy it and then update what you need to update, and everything should work. So it's nothing really too complicated. So next, we're going to push the code, and then we're going to start the build. so that we can see that it's going to build the image and then push the image to this repository right here. So when we come back here and we refresh, we should be able to see the Docker image. So once we have an image, you can already see that it's going to be very easy to run the application because we already have the image. It's only a matter of running the image as a container. Okay, so that's what we're going to be working on next. So I'm going to go back to the code and I'm going to open the terminal and I'm going to select git bash because I don't want to use the command line from Windows. Well, I guess since I'm on a Windows computer, it's still Windows. And then I'm going to say git add a dot so that I can add all the file, and I can do git status. I can see the 2 files that I'm adding, and then I also remove a space in the controller, so it's also detecting this change. And I'm going to say git commit -m so that I can pass a message, and then I can say edit build spec and Dockerfile. Press enter and then git push origin master, and that should do the trick. I'm gonna do log out. Oops, just to close this thing. Okay, so now the code should be pushed to the repository, which means if we go ahead into the code build, so in here in our project, and I say start build, it should pull this code and then start the building. But before we do that, code build, so this project that we have inside of code build, as you can see here, we're in code build project, and then we have our project, which is the CI/CD pipeline. It needs permission to access ECR. So you won't be able to push the image, or you won't even be able to log into ECR because it doesn't have permission. So we need to look for the role that we assign to code build and then give it permission to access ECR. So let's do this. So I'm going to duplicate this tab, and then I'm going to search for another service called IAM. So IAM is like manage access to AWS resources. That includes application resources or AWS resources, or a user like me, like you can see my name here as the user. So if you want to manage access both from a user point of view or from a resources point of view, so one resource accessing another resource, you can see that I'm trying to make code build access Elastic Container Registry. So I need to give code build permission to do that. And we know that code build has one role. So we're just going to give that role permission to access ECR. So let's go here, and then we want to go to roles, and we should be able to see it right here. So the CI/CD pipeline service role, which is associated with code build. You can see it here. So I'm going to select it. Okay. And then we can see that it has 2 permissions, and they're both for code build, but we need to give it permission to ECR as well. So I'm going to click on add permission, and I'm going to click on attach policies. And then here I'm going to search EC2 containers, and you can see the first 2, Amazon EC2 container registry full access. So we need to give it that. And we also need to give it the power user for container registry. So I'm going to give it that, and then I'm going to say add permission. Okay. So now this role, the CI/CD pipeline service role that is associated with code build, has access to ECR, the Elastic Container Registry, which is this right here, because it needs to log in and then push our image inside of this repository. So now we should be good to go to run the build, and we should be able to see our Docker image pop up in here. So let's go ahead and try that. So I'm gonna close this IAM, and then I'm just gonna refresh this, and then I'm gonna go ahead and click on start build. So this might take some time, and I'm gonna click on phase detail because this is a more condensed log of the process, and then we're just gonna watch it go. Okay, so I'm gonna fast forward the video. So it looks like it failed. As you can see here, we have 2 failures, and I'm gonna go back to build logs. There's gonna be like a detailed log of everything that was happening. And I'm gonna scroll down to see what this is about, and I can see that it says release version 21 is not supported. So the version 21 is not supported. So let's go back to the application, and I'm gonna go to Dockerfile. So I'm not specifying anything here. So it's looking at the POM file, and it's looking at this version 21. Okay, so we can just comment this out. It will just use the default version. Okay, so I'm gonna comment it out, and we're gonna do the same thing again. Just gonna push this over. So I git add the POM file. Let me just use the up arrow key. Let's say remove Java version, and then we're gonna push it again. Okay, so now if we go back to the repository and refresh, we should see the remove Java version, the commit. Okay, you can see this is committed out, and then we're gonna go back here. Well, we need to go to the build. I'm gonna go to build project. Okay, so this build project right here. So we have 1 failed build run. Okay, and then I'm going to run another. So I'm going to say start build, and I'm going to click on phase detail so that we can see a condensed log output. Okay, so I'm going to let this run again, and then I'm going to come back when it's over. So everything was successful. You can see we have success everywhere. So the pre-build, the build, and the post-build, they've all been successful, which means that our image was created and it was pushed to our ECR, okay, or to the repository. And if you want to see a detailed log, you can just look at the build logs. I prefer to look at this so I can see that which phase is passing and which phase is failing. It gives me a very pinpoint idea of exactly where the code is failing. But also you can look at the build logs, which is gonna give you all the details of everything. So I just click it and you can see how long this page is. Okay, so I can scroll all the way down and you'll see all the logs, everything that happened. Okay, so everything was successful. You can see at the bottom it says succeeded. Okay, so we should be good to go. So now if I go to the registry and I refresh it, and voila, you can see our image is here. So this is the image of the application. So let's go back to the image again, just so that we see where we are. So we were able to do all of this all the way up to this point. We as the developers, we have the application, we push it over to GitHub, and using the AWS code build, we were able to take the code, run a bunch of commands to read our Docker file, and then create the Docker image, and then push that image to ECR. So now we need to connect the rest of this together. So all of this should be connected to the ECR. So now we're going to be working with the ECS, which is the Elastic Container Service, which is a service for running containers. So that's what we're going to be working on next. So to work with the Elastic Container Service, we need to create something called a cluster. So the cluster is like an environment where all of your containers and services and tasks are going to be running. All of this is very abstract. There's really not enough time for me to dive into every single aspect of these services, but I'll just show you how to use them very quick. So I'm going to duplicate this tab, and then we're going to go to ECR. So I'm going to search, well, not ECR, ECS. And this is the Elastic Container Service. And then I'm going to click on it. So Elastic Container Service. And here what we need to do first is to create a cluster, okay? Because the cluster is like a space where everything's going to exist. So we're going to create a cluster. And we're going to just give it the same name. If I can scroll up here, I'll give it the same name, CI/CD pipeline cluster. And I'm gonna scroll down. We're gonna be using Fargate. We're not gonna be managing the EC2 instances ourselves, so the actual computers that will be running our application or our containers with our image. So we're not gonna be managing them. AWS is gonna manage it for us. And then I'm gonna scroll down. I don't need any monitoring and I don't need any tags. So I'm just gonna say create. And that's going to go ahead and create our cluster. We're just going to give it a second to finish. So our cluster is created. You can see it here, CI/CD pipeline cluster. And if you go inside, it's really nothing. It's just a space or an environment, like I mentioned. But one thing that's really important that we need to define is something called a task definition. So the task definition is like a template where you're going to say, hey, this is my repository for my image. This is where you need to pull it whenever I want to run some services. Okay. So whenever you run a service, it's going to look at a task definition to run the different services. So let's click on task definition. And you can see that I have one here, but I'm not going to be using it. I'm just going to create a new one. So I'm going to say create new task definition. And then I'm going to say new task definition because I don't have a JSON file. So I'm going to say create new task definition. And then I'm going to say CI/CD pipeline task definition. Just going to keep the same name so that when I'm deleting, I can delete everything with CI/CD pipeline. And I'm going to scroll down. We're still going to be using Fargate. So serverless computing for containers, because we're not going to be managing any EC2 instances. And then I'm going to keep scrolling down. Operating system architecture is fine. We don't need to change this. The CPU and the memory is okay. So we're going to scroll down. And then for task role, I'm just going to select the ECS task execution role. And then I'm going to scroll down here. Now, this is very important. So that's for the container definition. So that's why we're going to say this is where our image is going to exist. So we know we already have the URI. So I'm going to go back here and then go to repositories. And we need to copy this URI. So copy that and then paste it here. Okay, so this is the URI of our image or the location of our image. And we can also give it a container name. So a name for the container whenever the container is running. So I think we have this defined in the Docker and the build spec file. So I'm just going to use that same name. So CI or CDCI container. So let's put that here. Okay, so that's the container name. And then we're going to scroll down a little more. We're exposing port 8080. So we want to make sure we change this to 8080. If you remember, if we go back to the Dockerfile, well, we know that the Spring Boot app is going to be running on 8080. So in the Dockerfile, we say that we're going to be exposing that same port. We also have to do this in the task definition. Okay. So we're exposing 8080. That's the port that the container should expose. And the protocol is HTTP. And we're going to scroll down some more. All of these options are okay. We don't have to change anything here. And I'm going to scroll down some more. And all of this is okay. We don't need any health check. So we can scroll all the way down. So everything looks fine. We don't need to change anything here. And I'm just going to scroll down and click on create. Just give this a second. So this is our task definition. So the CI/CD pipeline task definition, which is pointing to our Docker image URI or our container, and it has the definition for our container. Okay, with where to pull the image, the name of the container. So now we just need to go back to the cluster and then run a service. And the service is going to use this task definition, and it will know where to pull our image and then run the service, which is going to be running the container. So the service in AWS is like a wrapper around the containers. So let's go back to the cluster. Go inside of our cluster, and then we're gonna say create service. I'm gonna click here, and we're gonna scroll down. So it's gonna select our existing cluster because we only have one, so you can see it's selected here. And I want to select launch type because we want to launch tasks directly without the use of a capacity provider strategy. This is for like a more complicated setup. So we want to select launch type, and then I'm gonna scroll down. And we're using Fargate, so this is going to be the same. We can leave the version to latest, and I'm going to scroll down some more. And really important is the family of the task definition, because we need to specify that so that it knows how to build the Docker containers that is going to try to run. So this is our task definition. So the CI/CD pipeline task definition. So you're going to select that, and the revision is going to be the latest. So whatever the latest is, it's going to take that and run it. So the latest tag for the image, and a service name, we can just make one up. So I'm going to copy this again, and I'm going to say service name, and then I'm going to scroll down. So this is where you specify how many tasks that you want to run. In our case, since we're going to have a load balancing, just to make it make sense, we're going to put maybe like 3, okay? So that you can load balance between the 3 running tasks. So every time we run this service, it's going to run 3 tasks, which is going to be like 3 different containers. So running the same app. Since we're going to have a load balancer, then the load balancer can load balance between these 3. Okay, so hopefully this is coming together. And I'm going to open the network, and I'm going to select all the defaults. So they've already been selected. And then I'm going to scroll down. The security group is like when you're going to open port so that you can access the running application. We can keep the default, which is this one, and then we can update to open ports later if we need to. I don't think we have 8080 open, so we might have to open 80. And then I'm going to scroll down. So for the load balancer, you can see here we can select application load balancer. And if I select it, you can see it says create a new load balancer or use an existing load balancer. And if I choose use existing load balancer and I drop down this list, you can see that I don't have any load balancer. So before we want to go ahead and create this service, it would make more sense if we can have the load balancer and then put everything behind it, because we won't be accessing anything from the services themselves. We want to put everything behind a load balancer because we want AWS to load balance everything for us, so we don't have to do it manually. So we're going to go back and create the load balancer, and then we're going to come back here and then select the load balancer, and then we're going to click on create the service. Okay, so let's go ahead and do that now. So before we go creating the load balancer, let's take a look at the image real quick. So right now we're in ECS and we're defining a service which is going to spin up different containers. But remember, the users of our application, they will have one URL, which is going to be the load balancing URL. And that's the only URL that they're going to be aware of. It doesn't matter how many deployments we do here, how many containers we have running here, if the application is scale up or scale down, they will only have one URL that they're going to use. And this load balancing is going to distribute the load between the different running instances of your application. So that's usually a typical setup for a decent sized website where they have like a lot of users. So let's go back and let's duplicate this one more time. And we want to go to another service, and this is the EC2. So I'm going to type in EC2. We're going to click on this one. And what we want to do first is to define the target group, because we're going to point the load balancing to the target. And if you look to the left here and I scroll down, you can see target group. So I'm going to select that. You can see I have nothing here, and I'm going to say create target group. And then here I'm going to select IP addresses, and I'm going to copy this name one more time, copy, and I'm going to scroll down and give this the name. So target group. Okay, and we know that the containers, they're exposing 8080, so we're gonna say 8080. Okay, IPv4 is fine with me. HTTP1 is totally fine. For the VPC, this default one is already selected. Okay, I don't have to do anything here. And then I'm gonna scroll down for health check. I really don't have any health check, but we can add one later. Okay, so it's looking at the root of the application, so we can put something in the root so that it can go to some health check or something. And we can expand this advanced. You can see the healthy threshold and unhealthy threshold. So if you want, you can change these numbers, but I'm cool with these because I'm gonna delete this anyway, so I don't have to change anything here. So I'm gonna scroll down and then click on next, and then I'm gonna leave all of this as default, and then I'm gonna click create target group. So the target group has been created. So now we can create the load balancer. So let's go to load balancer, and then we can click on create load balancer. We're gonna select the application load balancer. Again, there's a lot here. I just don't have time to explain everything. So let's keep moving. So here we're gonna say load balancer. We want it to be internet facing. We're gonna access this load balancer on the internet. IPv4 is fine. We can scroll down and we can select as many regions as we want to for high availability, but I'm gonna select US East 1, and this is totally fine with me. US East 1B, yeah, I can select all the US East 1, okay? Just for high availability, but you don't have to do that if you're just doing some testing. And then here we're gonna select a security group, and it's using the default, which is totally okay. And I'm gonna scroll down. We want it to listen on port 80 because it's gonna be a simple URL. So 80 is the default for insecure HTTP connection. So that's totally fine. And then here we can select our target group. So you can see it says select target group. So we're gonna select the target group. So this load balancer is gonna be pointing to this target group. Okay, and I'm gonna scroll down and everything else looks okay. We don't need any tags or anything. And then I'm gonna click on create load balancer. So the load balancer has been created. We can view it and you can see it right here. I can select it and you can see all of the information about it. So now we can go back to the service and then select that load balancer so that we can load balance and scale up or scale down if we need to, but we will only be using the load balancing endpoint. Okay, so if you go back here and then scroll down, you'll see the DNS info here. So this is the name that we're going to be using to access our application. Okay, so you're going to see all of this in action, and it's really a lot, and I would really encourage you to go back and watch the videos again or look at this picture again so that you can understand what we're doing. But nothing in the cloud is like straightforward. Whenever you need to set a number of services together to run your application, then it's going to take some effort, and you really need someone to know exactly what they're doing so that they can do it properly. So next thing we're gonna do, we're gonna finish our service and then we're gonna take it for a spin. So we're gonna continue that in the next lecture. So I'm gonna scroll down and select use existing load balancer, and I'm gonna click on the drop down. Now we should see our load balancer. So I'm gonna select it, health check grace period. I can say maybe every 15 seconds we want to check if it's healthy so that we don't keep pounding it with requests. And then I'm going to scroll down and we're going to keep port 80 because that's where the load balancer is going to be listening for requests coming in. And then I'm going to scroll down again. We're going to select an existing target group. Okay, and then I'm going to click here. This is our target group, so I'm going to select that, and then I'm going to scroll down, and we don't need any auto scaling. However, this is really important because this is where you would configure your auto scaling, like if you want to scale up or down. But we're not going to get into that. This is even another layer of complexity that we don't even have to get into. And then I'm going to click on create service. Okay, so the service is being created. It says it can take a few minutes, so I'll come back whenever this is over. So this has been going for a few minutes. I'm going to refresh, and then I'm going to go to tasks. So I can see the service here and it says it's running. So if I go to tasks, I can see I have 3 tasks running, and the health status is unknown because I don't have any health check endpoint, but I can see that they're running. They haven't failed. Okay, so that's good. So now we should be able to access the application using the load balancer. So if we go back to the load balancer, we copy the DNS name and we go to the browser, and this is the moment of truth. So let me open our application and check out what we have in a controller. So we have test. Okay, so let's go here /test, press enter, and let's see what happens. Okay, it looks like it's hanging, and I kind of already know why. So it's probably because the port, which is port 80, probably because it's not open. So I'm gonna stop this. Well, I'm gonna paste this in anyway, but I'm gonna go back here and the load balancer. So this one right here, actually I wanna go to EC2, and I'm gonna select that. And then I want to go to the security groups. So this one right here. So I'm going to click on this one, the default one, and you can see it's only opening port 3306. Okay, so I'm going to click on edit inbound rule, and I'm going to say add rule, and we're going to open the TCP, which is going to be port 80 and from anywhere. And I'm going to do the same for port 8080. So TCP again, and then 8080 from anywhere. Click on save rules. I can pretty much do the same for all the other ones. So security groups. So all of these ones, if they don't already have it, should be click here, open them up. So this one has 3000. So I'm gonna add all these port 80. I'm gonna change it to 80 from anywhere. Add another one, TCP 8080 from anywhere, save. Okay, I'm gonna do the same for this next one. Edit inbound rule. So it has an HTTP already, so I'm gonna put port 8080. Put it from anywhere, save, and I'm gonna do it for this one. I don't know which one that I'm using, but I'm gonna edit all of them. I think that's everything. This is a one that I'm using for something else. So we did the default one and we did these three. So let me double check again these three just to make sure that they're open. Okay, 80 and 8080 for the first one, 80 and 8080 for the second one, and the third one, 80. Gonna open 8080 as well. And I think for the default one, we already have 8080 open. Yep. Okay, so I'm gonna close everything here and I'm gonna try this one more time. Okay, you can see our application is running because that's coming from Spring Boot. And if I do tests and give it a second, and you can see testing up and running. Okay, you can see that we're not using any of the container IP address or the target group. The target group is like a group of EC2 instances. So if we go to the instances and we go down to target groups, we click on the one that we created, you can see all of these IP addresses. So these are the actual instances where the code is deployed. I don't know if I can access them using the IP address, but I'll try anyway. So let's go here. Nope, so we cannot. Okay, so I'm gonna close this. I didn't think we would be able to, but these are the actual, not these ones, the security group ones. These are the actual EC2 instances or computers where the Docker images are running, because we specify that we need 3 for the replicas. So if we go to the cluster, you can see we have 3 running, where we have some activating, but we have 3 running. Then we have 3 instances. As you can see here, we have 3 instances. So you can see the health status is unknown. And also if we go back here, you can see it says unhealthy, even though they're healthy. That's because it's sending a request to the slash and it's not finding anything. So it's a 404, not found. So that's why it's giving us this unhealthy, but it should be healthy if we put in some new code. So that's exactly what we're gonna do. So we're gonna do that once we have another revision for this, but I'm gonna show you how we're gonna fix this in just a second. I know this is a lot, and really when you're in AWS or doing anything in the cloud, nothing really is very straightforward. You just need to know exactly what you're doing so that things can work. So I would encourage you again to go back to the videos and ask me questions if things are not working, and if you want to set up a CDCI pipeline using AWS. Okay, and again, don't worry about the health check. We're gonna go ahead and fix that in just a sec. But you can see now, using this load balancer URL, we can access our application. Okay, and every time we send a request, it's gonna send the request to the list busy running instances of our application in Docker, okay, which is running inside of a task, which is wrapped around in the cluster. So it's a whole setup just to get this to work, okay? And we don't have to worry about scaling up or scaling down. If we had the definition, remember in the option where we put configuration for scaling up or down. So if we started having a lot of people accessing our application, it would distribute the load properly. And you can do that automatically, or you can do it on a schedule. If you know that more customers are going to access your site on a specific day of the week or a specific time, then you can put a current schedule to scale up or down. So lots of cool stuff that you can do using AWS. So if we go back to the image, we have all of this done. Okay, so we have the load balancer, which is one URL that is pointing to a target group. That target group is looking at EC2 instances that is running in our ECS, so the Elastic Container Service. And the Elastic Container Service is using an image that is pushed inside of this registry, which is coming from code build, which is pulling the code from our GitHub Repository. So the only thing that is left is to be able to do one commit from the developers to GitHub and then trigger this entire process and then redeploy the application. Now, the cool thing is you don't have to do anything past the code build pipeline. And once we push the code to GitHub, it's going to trigger this process, which will create a new image, like a new Docker image, which is going to be pushed in our ECR. And once ECS sees that the image was updated, it's going to say, oh, I need to rerun these 3 tasks. So it's going to stop the running task and then run 3 more. And our code will be updated all the way. So all of this from ECR to ECS to the tasks running in the containers to the target group to the load balancing, we're not touching this anymore. We just need to use another service here so that when we push some changes to the repository, it will trigger this entire process. But all of this is already done. So you can see how this is coming together and how useful it is for like a lot of businesses when they need to run and can have downtime and need to push the code, make updates, and not experience any downtime in their business. Okay, so that's what we're going to be doing next. We're going to be configure so that whenever we push changes to GitHub, it can trigger this process, which will build a new image and push it to the registry, which is this. And ECS is looking at this registry, and when it sees any changes or any updates, it's gonna say, oh, I need to redeploy, and then it will redeploy the containers, which is running inside of task, which is pointing to this target group, which is pointing to our load balancer. So all the changes will be reflected whenever we access the application. So that's what we're gonna be working on next. So now let's go ahead and start setting up the AWS code pipeline. So let's go back here. We want to go to, let me just go to EC2 and let's search for pipeline. Okay, so code pipeline is the one that we're looking for, and we're just gonna create a new one. So you can see again, they're all coming under a developer tool. Okay, so in the presentation, I should have named this developer tool, but this can be confusing. So I just kind of put AWS code pipeline. So in the pipeline, we're just gonna say create a new pipeline, and this is gonna be pretty straightforward. So let's copy this name one more time and go to our pipeline. I'm gonna say CI/CD pipeline. Pipeline. I'm just gonna keep it like that. And version 2 is the one selected. We want to create a new service role, which is gonna be this one. That's totally fine. We want to check this, so allow code pipeline to create the service role. And we're gonna scroll down, and I'm gonna open advanced settings. We can keep all of this as the default, and then I'm gonna click on next. And here we have to provide the source. Again, where is the code coming from? So I select GitHub version 2, and now we can connect to GitHub. So we can say connect to GitHub, and it's gonna give us this pop-up window. I can just give it any connection. So I can say GitHub connection, and then click on connect to GitHub. I'm logged into GitHub to this browser. If you are not, then it will just ask you to log into your GitHub account. So I'm gonna authorize, and it's gonna say you're being redirected. Okay, so now I can install the new app. You need to do that. Okay, so it's really important that you click on install new app and let it finish, and we're gonna give it permission again. There we go, and then we're gonna say connect. Okay, so now you can see it's connected to GitHub. I'm gonna scroll down. It's gonna ask us for the repository. I have a lot of repositories, so I'm gonna select the CI/CD pipeline repository. Okay, so I'm gonna select that, and we want to trigger this pipeline whenever there's a push in a branch. Okay, we're gonna specify which branch. So I'm going to scroll down, and it should find the master branch because it's the only branch that we have in this specific repository. If I had multiple branches, then it would ask me to select which one it has to listen to the push on so that it can start this pipeline. And I'm going to keep the code pipeline default, and then I'm going to click on next. And now it's going to ask me for the build provider. So this is the build that we created. So that's going to be the AWS code build, not Jenkins. And then here we're going to select the project. So this is the CI/CD pipeline. Okay, so that's the only one that we have. And I'm gonna scroll down, and then I'm gonna go ahead and click on next. We can leave the single build. We're not doing any bat. So click on next and code deploy. So this one is ECS because that's the deploy provider. And now we have to select our cluster name. This is the cluster name, service name. That's the same service, and everything else can stay the same. We don't need to provide the image definition or anything. And we don't need to specify any deployment timeout. And then I'm gonna click on next. And this is a summary of everything that we have selected. And then I'm gonna click on create pipeline. So the pipeline has been created, and it's also gonna go ahead and start the pipeline. So I'm just gonna watch this go through, and then we're gonna come back whenever this is over. So I see that this is taking a little longer. So it's been running for like 2 minutes or more, and it looks like it's succeeding. So we're just gonna let it run. But what I want to do is to go back to the application, and I'm going to add another endpoint. So I'm going to add another one here, and I'm going to remove the request mapping. I'm just going to comment it out. And for the first get, I'm going to put tests or /tests. Okay, so this one is going to go to tests, and then I'm going to say health check. I think we brought in, so if we go back, I think I put in the actuator. Okay, so this is the actuator. We could use the actuator health check to look at that, but you guys can do that. But remember, in our AWS configuration, we specified that the / would go to the health check. Okay, so I'm not gonna spend time to do that. If you want in the AWS configuration, you could choose to point to, actuator health check. And I'm gonna say status, and we're gonna say up. Okay, so the health check is gonna point, well, I'm gonna put it first. You don't really have to put it first, but I'm just gonna put it first. So if we go to the root, it's gonna go to health check. The status is gonna say up. And if we go to test, it's gonna say maybe test data. Okay, so testing, test data, because we need to push these new changes so that it can request this endpoint for the health check, and it will return a 200 so that it will know that it's up and running. So let's see if the build is successful. So okay, it's deploying now. So we're gonna wait until this is finished. We're not gonna see any changes because the app is still the same, the code is the same. But after this is complete, I'm gonna go ahead and just push this code to the repository, and we should be able to go to test. It will give us testing, test data, and the health check should be healthy because it's gonna be sending requests to the root, which is gonna hit this endpoint, and it's gonna return status is up, which is a 200. So it's gonna be considered healthy. So let's go back and wait until the deploy is complete. And once that's done, then I'll come back. So while this is taking a lot longer than expected, if we go back to the cluster, you can see that we have tasks that are ending. We have tasks that have started a minute ago. So if I refresh it, you'll see that some have been started 2 minutes ago, some have started a minute ago. It's gonna be deleting tasks and creating new tasks as we do new deployments. So whenever we push the new code, which I haven't done yet, it's gonna stop the ones that are running and spin up new ones because something was changed in the registry. This image was changed. So as of right now, we only have one image. We haven't pushed anything else yet. So it's going to redeploy everything whenever this deploy is running, and it's going to restart these containers that are running. Okay. So this task, they're like, a task is a wrapper for running containers, and a service is a definition for how a container should run. Hopefully this is making sense, but you can consider these as running container. Okay, so let's go back and wait for this to finish. Gonna refresh. Okay, it's still going, so we're just gonna wait and then let it finish, and then I'll come back when it's over. And in the meantime, if I go back here again, see now we have 3 more. So if I refresh, you can see now we have 3. Earlier we had more, but now we had 3 because the ones that it's not using, they got deleted. And then it's gonna spin up new ones. Okay, you can see these have been spun up. It's been 3 minutes. So let's go back here and wait for this to finish. The deploy is gonna take a little bit longer because it has to spin up all these containers and things like that. So this is like a true real world CI/CD pipeline that we set up, and these can take some time. Obviously the application is not a real application, but that's not what we're trying to demonstrate here. We just want to show the CI/CD pipeline. So that's why it's taking a little longer, because it's an actual deployment that is taking place inside of our cluster. Okay, so let me refresh this again. Okay, so I'm just gonna wait until it's over, and then I'll come back. Okay, so it's still taking a long time. You can see it's been deploying for 9 minutes. In the meantime, let's go back to our application and then just push the code. So let's go here, open the terminal. I'm gonna clear, I'm gonna do git status to see. Okay, so that one file has been updated. So we're gonna do git add. Okay, so we should add everything. Okay, and we can do git commit. This is going to be updated, controller, enter, and then we can push. So when I do this git push, it's gonna trigger the entire pipeline. So let's do git push. Okay, so the code it's been pushed, and let's go back here and let's go back to the pipeline. It's still in progress from the previous one. So let's go inside. You see now it's back to source and it's building again. Okay, remember we were in deploying. So now it's already see the change. You can see it says just now, because it just saw that there was a push to the repository on the master branch. So it's repooling everything and then do the deployment again. So once this is completed, hopefully all of the unhealthy that we're seeing here will be gone, okay, in the target group, because we define the root for the health check. Okay, so the root would be this first one. It's gonna say status up. Whatever we put in the response body, it doesn't really matter. It's looking at the HTTP response, which we're passing in 200. Okay, so let's go back here and go back to the pipeline. This time I'm just gonna let it go through and then let it finish, and then when it's over, it's completely done, I'm gonna come back here, and if I refresh, we should see the new code. And if we go to the root, it should give us the health check. Okay, so let's go back here, and I'm just gonna let this finish, and I'll come back when it's over. So I can see that the build is completed. So now we're just doing the deploy. Let me go back here. If we go back to the cluster and refresh, we should see 50 seconds ago. And this one is 42 seconds ago. So it's spinning up new containers to run our application. And these containers are living inside of a target group, which is sitting behind a load balancer. So we're just gonna wait until the deploy is complete. and then we'll go back here, refresh our page, we should see the new changes. So let's go back here and let's wait for the deploy to finish. So the deploy is finally complete. I'm gonna refresh it one more time just to see how long it took. So it took about 28 minutes. So now if I go back to our app and I try to refresh, and you can see it says testing load data. And if I duplicate this, and if we go to the root, and you can see it says status is up. Okay, so our application is running as expected, and it's using this load balancer. So this is distributing the load across the different instances of the application that we have running. And if I go back to the cluster, you can see we have 3 replicas because that's what we specify. So you can see it says running 3. And if I go to the target group, you can see we have our 3 running, listening on port 8080. So this is what's sitting behind the load balancer. So this load balancer that we define here. So this one right here, okay? You can see it's gonna forward the traffic to this target group that we were just looking at. So hopefully everything works for you guys and you didn't have a lot of issues, because this is not an easy setup. And a lot of times you don't even have to do this. It's gonna be done for you as the developer. There's gonna be like a DevOps team. They're gonna just set this up for you. You just have to code and push your code. But in case you are a DevOps developer, then it's good for you to know all of this stuff. And I'm gonna go back to the load balancer, open the target group. We should see the healthy. You can see now it's healthy because the endpoint that is checking for the health check is the /. You can see here the path is /. And when that happens, then it's going to return this 200 OK, which is going to be the body of the request is going to be status is up. But as long as it's a 200, then it's going to, specify that it's healthy. You can see we have 3 healthy and then 0 unhealthy. Okay, so everything is working as expected. And one thing you really have to do is to delete everything that you created. It's also going to create some S3 buckets. So you can go to your AWS account and then just go to all the resources that are being used, and you can go one by one and then just delete them. But it's really important that you delete them. Otherwise, they're just going to stay in AWS. You're just going to keep incurring cost. And you don't want to do that unless you really want to set up something for real. But if you're just practicing, so make sure you go back and then delete everything, like literally every resource that got created during this process. You want to go ahead and delete all of it. Otherwise, it's going to cost. Okay, so our application is up and running. You can see the new test data, and also the endpoint for the health check is also working. So now it's up to you to take this and then implement it on a very large scale or on a real world application. And real world application will probably require you to configure some of the more detailed or fine grained configuration, because you want to take advantage of AWS and then make sure you minimize costs. And in order to minimize costs, you need to really configure things to the finest detail. So a lot of the things that I say, hey, we can keep this as the default, you'll have to go back and then really look at them and what they do and then configure them. So like I said, it's not an easy setup. It's straightforward, but you just need to know what you're doing. But for someone who is just beginning with AWS, then it might not be a very straightforward process. But we have implemented this entire workflow. So we have the load balancer. It's pointing to a target group. These containers are running inside of this target group. So we will have 3 EC2 instances, and each one of them is running on a container, and the load balancer is just distributing the load across the instances that we have. And all of this is running on a cluster in ECS, which is looking inside of this registry for whenever there is an update or there is a new image, which is going to be created by this pipeline right here. So we push the code because we have the build spec file. It's going to build the code, read the build spec file, and then push the new image to ECR, and then it's gonna deploy the code to ECS, which will spin up this entire flow, and then we can access the application using the Elastic Load Balancer. So again, if we go to ECR, so if we go back and go to ECR, so if we refresh or if we go in here, we should see multiple different images, because every time we do a build, then it's gonna rerun and then create a new image, and then it's gonna tag it with latest. So whatever is the latest is what the cluster, so the ECS cluster, that's what it's going to use to spin up these containers that are going to be running inside of our target group. Okay, and the target group is sitting behind the load balancer. All right, so everything is good. We have our CDCI pipeline in place. You can see we make one change and the entire flow is triggered until the code is deployed, and then we can see the new data that we entered. And I'll open that up one more time. So remember, we made this update right here. Okay, test data. So that's what we're seeing. Okay, so the different message, and also we have our health check, which is just the root, and its returning status is up, but you can put whatever you want here. Or you can use the dependency that we brought in, which is the actuator. So you would have to go to actuator/health instead of going to the slash. So you would specify that in your configuration in AWS. Okay, so if you have any questions, let me know. And again, one more time, don't forget to delete everything, delete repositories, delete the cluster, delete all of the code build, the projects. Just make sure you delete everything so that you don't have to pay a lot of money to AWS. So if you have any questions, you can join the Discord. I'll leave a link in the description so that you can ask me your questions, or just ask the questions here in the comments. I should be able to help you. And I think this is the last section of the course. So I really congratulate you if you made it all the way here. That means you really learned a lot. And of course, you have my contact information. So if you have any feedback, any suggestions or ideas, I would be glad to hear them. But until then, happy coding, and I will see you guys in the next one.